Good morning. In this video, I will explain how we can modify the some of the specification inputs for TowGeom so that all the sheets in the TowGeom outputs created in the TowGeom outputs, how actually those things get updated. Example, you want to modify the wind pressure or the gust drag values or the person connected member force. You can see how actually these files get updated. So in order to that one, open the latest generated output file, go to the project's data and review the data and accordingly modify the specifications that as per the project requirements. Let me open to the same output file that what you have generated output file underscore here demo is the username, so you will see the username here. Let me go to this specification sheet, project specs. Now take an example. Suppose if you want to change the yield strength, and then accordingly when you change the yield strength, you have to go back to all the inputs. Let us say I will change it to 345. So the moment when I change it to 345, you can see the sheet here get updated, and you can see the angles database etc. get updated. So when once you have changed this yield strength, you have to go back to the PLS, copy the inputs to PLS and rerun again and get that output data to these sheets. Again, let us say if you change that diameter of this bolt, you can say, let us say from 16, if you make it 12, you can see how actually the bolt database get updated. Earlier it was 16 diameter, now it has got changed. Let me go back. Let me say undo, or let me try to change it as 16. You can see how it gets updated in this bolt database. Now you see that it has become 1.6. Like this, the data, and you can see the shear strength also got updated based on the bolt diameter. Similarly, if you see here, we have the connected member force here. Let us say instead of 2.5, you want to make it as 1.5. Change it to 1.5, and you can see that in that last sheet where we call it as a redundant design, you can see the program gets updated. Actually, we'll see how it gets updated in the redundant design. There is another video for redundant design. I will explain how it gets updated here in that one. Going back to the specification sheet, we can see how what other parameters gets updated. Now we have wind pressure on the tower. Now here it is 71.49. Now let us say if you see here, we have wind calculation 0 degrees, where you can see that the program is computing the wind load based on the wind pressure of 71.49 kg per square meter. Now we want to update it to, let us say, some 80 kg per square meter. In order to do that, go to the project specs. You can see, you can know these values. It is 28442111 You can see how those values get updated. So instead of 71.49, I'll make it as 80. I'll change it to 80. Now let me go to see the wind calculation sheet, and you can see um, now you can see the program has computed for the revised wind pressure, and accordingly the wind nodes also getting updated. Similarly, if you see that the gust and drag values are not as per the project, you can change it here. Let me show you how actually it gets updated. Let me show you where here we have the drag values, right? Where is the solidity ratio? Here it is 0.1, or here it is 0.12, where it is 3.29. Let us see how it gets updated when we change this one in the project specs. It is between 0.1 and 0.15. Solidity ratio between 0 and 0.15. These are the values. Let me make it as let us say let me make it much more different. I'll make it between 5 and 4. You can see how it gets updated here in the wind calculation sheet. You can see that the program has drastically changed this value based on the drag values. Like this, the program has got inbuilt functions which update all these wind load values based on the inputs that we have in the project specifications. Similarly, we also have drag values here and gust values also, gust tables, when one user can modify those values accordingly. Similarly, we have the bending load for designing the redundants for bending check. These are the values the program considers while doing the redundant design that we will see how it takes care in the redundant design. Similarly, we also have ice thickness parameter. The moment when you change the ice thickness, the program updates the ice thickness values accordingly. Let me explain how actually this ice thickness works here. Here we have different sheets for transverse and longitudinal wind area. Let us say transverse on long face wind area. You can see the wind width as 15.6, 4.5. Suppose if I change this ice thickness here, you can see that the program updates. Let us say once here it is, let me make it as a 10 centimeter. Probably this might be a big value, but to show you the difference, you can see how actually it gets updated. You can go to the transmission area and you can see how this value is getting updated here based on this. Okay, we'll check this one why this is not working, but this is how it should work, but we'll make sure that it works. But here if you see, it has got a link directly to the project specs, so we should directly update these values. So this is how we can modify the specifications, project specifications, and accordingly how this output of a TowGeom can be updated. If you have any questions, please feel free to email us. Thank you for watching this video. Thank you.